All right, here we go. All right, so factor tree. What's the factor tree for 75, Nathan Miles? What'd you do?
I did 25 to 3.
Okay, did you go any further?
Yeah, I did 25 turned into 5 to 5.
Okay. Good. Alyssa.
Why do you 5 times 3 and you get 15 half of 3?
You're so smart. So we had a pair of fives. So we pull the 5 out and multiply it times the 3. And the 3 was left over, just like she said. Any questions so far? Mary, what'd you do for a factor tree on 108?
I just put it to 12 and 9.
Then what?
And then the 12, 4 to 3. And then the 9, 3 and 3.
And 2 and 2? Good. Kendra, what'd you do with the 2 and the 3? Right, so the 2 and the 3 will come out, multiplying with the 5, or the negative 5, like you said, which would be negative 30. And we have a 3 left over. You guys see it there? So now we can subtract them because they're like radicals. And get negative 15 radical 3. Okay? So that's what we do for square root. What would have happened if I was trying to do cube root?
What?
Cube root. You don't know that? Oh, that must be something to learn later. You know what a cube root looks like?
Yeah, so sounds pretty cool though.
That's a cube root. You'd be looking, for square root, we look for groups of what?
3.
Well, for square root, we look for groups of 2. For cube root, we look for groups of 3. Yeah, that's all different. So we could do those if we had to. We will eventually. Okay. So, there's our practice quiz. You got the right one, don't I?
Yeah.
So, tomorrow's quiz will look very similar to this. Okay? And you should be, after today, you should be very prepared to take it. Okay? You won't have any homework tonight.
Yeah.
You won't have any homework tomorrow night. Okay? Only thing you have to do tomorrow is take this quiz. All right? One thing you might want to do is just do some more practice, or even maybe do this again, tonight, just to get yourself ready. So, for A, B, and C, I will always put what letter, what type of number are always going to be real. So that's one of the answers for each one of those, that they're all going to be real. So capital R. I'm just using the capital letters for them, but if you wrote out the whole word, that's okay. All right. So I'm just going down the line. Is this one irrational? The square root of 43. And irrational means when you write it as a decimal, it goes on forever. Right? It won't repeat, it won't stop. So Square root of 43, is that one of those? It is. The only type of square root that is not is what type under there? What's under the radical? Perfect squares, yeah. Okay, so if it's not a perfect square underneath the radical sign, then it's going to be irrational. And if it's real and irrational, we're done. It can't be any of the others, right? Autumn.
This is gonna sound really stupid, but what's an integer?
Integer is positive and negative whole numbers, no decimals or fractions, and 0 is in there too.
No fractions or decimals.
No fraction decimals for integers, whole numbers, and natural numbers. The rational numbers are when we get into the fractions and decimals. Have again?
So, how can you put the difference between like the integer and natural for both, like, if it's 3? Is there any difference, can it be classified as an integer and natural?
Yes, there can be more than one.
Okay.
So we would put both of those, yes. Okay, so for letter B, is that a rational number? As a decimal, will it stop or repeat? How could I write 1 as a decimal? 1.0, does it stop? Yeah, so is it rational? What letter were we using for that? Q. Autumn.
Do you have to write the letters, or can you just write out the words?
You can write out the words, it's okay. You don't have to have those memorized, the letters, if you don't want.
On the quiz tomorrow, how many points will it be off if you have like, if you're just missing one of them? Like if it's one, like rational, but I put all the other ones.
Probably a point.
A whole point?
We'll see. Depends how I feel when I start doing it. Maybe half a point.
Oh, great.
Maybe it's all wrong. I can't believe she didn't know that. So I don't know. Probably just a point.
How many points are each question?
I think they're all 3 points.
Oh,
Every answer is 3 points. Like 42 points. I think there's 14. Because we got 3 here. So extra 2, I guess. So we got a rational for 1. What's next in line? Is 1 an integer? Yeah.
Yes.
Is 1 whole?
Yes.
Yes. Is 1 natural? Yes, it's all but irrational. Remember the way I told you the naturals were, it's like I call them the counting numbers. The numbers you count with. When you start counting, you start with 1, right? And again, the only difference between the natural numbers and the whole numbers is the number 0. Whole numbers are 0 and up. And then integers would go on the other side of 0, the negatives, with the 0 and 1 and up. Okay? Yeah.
you said that 0 wasn't a natural number,
It is not a natural number.
so everything above 0.
Yes.
But
Whole.
negative,
Yeah, no negatives. So all whole numbers bigger than 0 are natural. Okay, it's like 1.5 is not natural. All right. 3.25, is that irrational or rational? Rational. Is it an integer? No. So if it's not an integer, it's not the other last two, is it? So those are the answers to those A, B, and C, number 1. Okay? All right, for number 2, it says use interval notation to represent a set of numbers. Okay? I might ask you to graph that set of numbers instead. Okay? I might say use set builder notation for that. Okay? So, you need to know all 3. Ava,
Like that line.
number line graph,
Oh,
yes.
okay.
Hannah,
can you explain interval notation?
yes. Okay? I'll just show you all 3 ways, okay? In case you run into one.
Yes.
Okay? So So if I told you to graph this interval, this set of numbers, I put negative 15 down here, 0 is going to be here somewhere, and 3 is going to be up here somewhere, right? You don't have to write all the numbers. Okay? How would I represent where negative 15 is? What do I put over top of it? Do I put a solid dot, a circle, a triangle, what? An open circle. Why is it open? We're not including because we just have less than, right? What about the 3? What do I put on it? A closed one, because we are including the 3, right? And that interval is at all the numbers in between there. Okay? So that would be a graph of that set. Set builder, you always start like this. You just start your set like that. And then you write an inequality. Well, they already gave us the inequality, right? So I just put that. And then close it off with a set brace. So that's set builder, but I'm asking you interval, okay? Interval notation is this kind of stuff. It looks like a point when you graph, right? 2 numbers with a comma between them. But sometimes there's parentheses, sometimes there's the bracket, the squared off one. Okay, the parentheses tell you you're not including the number that it's next to. And the bracket is telling you you are including it. So for this one, we're not including the 15 or negative 15, so it's parentheses. And for the 3, we are including it, so it's the bracket. So those are the 3 types of ways we were representing sets that we, we had this, a description too, right? But, so number 2 tomorrow, I'm going to give you one way, and you're going to tell me whatever way I ask you, one of those 3 ways. Hunter?
Are you gonna give us a graph of these negative 15?
Write it in set builder? I might give you a picture of a graph to start. Okay? So you should understand all 3 ways and what they're saying. Okay? Any other questions? All good questions. Anna?
Can you explain interval notation?
Which one?
The last one.
Interval again?
Well, you said it.
Okay. Set builder, you always start with these 3 symbols. The set brace for the left side, X, and then that line. That means such that. And then inside, you're going to write some type of inequality, which we're going to do with this bone that fits those. Okay, and then you just close it off with a set brace. Okay? So here is 2 intervals, basically. Okay, here and here. It says write this interval in set builder, so we're going to start like this. And then I'm just going to write an inequality for that and an inequality for that. All right? So since the parentheses is there with the negative 3, will I have less than or equal to? Just less than, because the parenthesis means we're not including the negative 3. And we put X, and then it's less than again. Will we put the equal to? Yes. So that's for this one, okay? And then that says or, so you just put or here. And then we have this. So X is going to be, it's from 5 to infinity, so all my X values are greater than 5, right? We're not including the 5 because it's a parenthesis. Somebody asked earlier if they could write it this way. And I said, yes, that's the same thing. Autumn?
Do you have to, can you, I don't know how to ask you, do you have to write it just like that, or I don't have to explain. I wrote it like the first.
Let me see how you wrote it.
Okay.
Oh, that's okay.
Okay, I got.
That's saying the same thing.
Okay.
You're just a little more wordy, that's all. But yeah, nothing wrong with that. Yeah, Autumn asked this, could she have done this? Yes, that's okay. If some of you others did that, that's okay. But you don't have to. Put the infinity part, but it's not wrong. Any other questions? This helping?
Yes.
Good. They're all good questions. I like that. All right, so number 4, I'm asking for 2 answers. You guys realize that?
Yeah.
Okay? I want the additive and multiplicative inverse. Okay? Additive, think of opposite. Multiplicative, think reciprocal. So here's our number, -1/2. What's the additive inverse? Positive 1/2, the opposite, right? Multiplicative, what's the reciprocal of -1/2? 2 over -1. Or if you wrote just -2, that's okay. But there's 2 answers. Okay? Every year I get somebody who gets in a hurry. You shouldn't be rushed in this, you know, it's only 14 answers, right? But they forget to do one of them. They'll do one or the other, but not both. All right, number 5, 6, 7, and 8 are radical problems, and I just want to simplify. I do not want you to put those in the calculator and give me some decimal answer, like this would be 8.9 something. All right, I want it in simplest radical form. I want you to simplify using your factor trees. Okay? So I'm going to go 16 times 5. And that's all the farther I'm going because 16 is a perfect square. So I'm trying to save myself a little time. The square root of 16 is 4. And then the 5 is left over. Okay, but if you went all the way down and got 4 2s and a 5, that's okay. You got 2 sets of 2s, right? So for each set of 2s, you bring a 2 out and multiply. Joe.
I get how you just did it, but like when we have like 4 2s and all that, how you do it then.
Okay,
I like when you,
so you went all the way down, right?
yeah, it's just like,
What'd you go, 8 times 10 maybe?
yeah, 8 10.
Okay,
It's like the easiest
so it went like that, right?
Yeah.
Okay, so for this pair of 2s,
Yep.
you bring a 2 out. For that pair of 2s, another, and then the 5's left.
What?
Well, what's 2 times, oh no, you already broke it down to 2 others, so you don't need to worry about that then,
Yeah.
okay?
And then you just-
See, I didn't break that one down.
Yeah.
Right? So then you just multiply.
Makes sense. Thank you.
You're welcome.
What happens if there was something outside of the like 8?
Right, if there was a number out there, then these 2 2s, I'd multiply by whatever's out there.
Okay. Thank you.
Okay? All right. I like to think of these as separate radicals. Can I simplify that? Can I divide 5 into 125? Yeah. Whenever 2 numbers end in a 5, you know 5 goes into them, right? And how many times does 5 go into 125? 25, right? 5 quarters is $1.25, right? Basically what that is, right? But this is nice. Why?
Perfect square.
Perfect square.
5.
So answer is 5. Now, every year, I get kids do this right, and then they put a radical sign in front with the 5. You guys understand, you don't put the radical sign here. Because remember, square root means what times itself equals that number. All right? And what times itself equals 25 is 5, right? Not the square root of 5. The square root of 5 times the square root of 5 is 5. Okay. These are all kind of mushed together, aren't they? All right, so we'll move this one over here. I hit black and it went green. What's the deal? All right, so now I have a 5 on top and a 5 on the bottom, so I can just cancel them, right? No. Ava,
I have a question about this.
go ahead.
I think this is the wrong bridge up, and I want to double check. I factored 125 with the factor tree.
Mhm.
Is that wrong?
No, you can do that.
I got 5 radical 5 when I did that over 5.
Mhm.
Is that,
Yeah, so you got this. When you did the factor tree,
yeah.
you got this, right?
Mhm.
Well, then you can just do that.
Yeah. So
And
wouldn't
then-
you just radical 5 again?
Oh, wait a minute. No, the bottom would be radical 5 still. My bad. You had me going there. Yeah, it actually, the bottom has still got the radical on it. We just did the top, right? All right, yeah. So actually, these two go.
Okay, I canceled out the one. I didn't give the
Oh.
one.
The radical, we forgot that the radical.
Yeah.
All right, let's change colors. Okay, so we're doing this one now, right? So I said you could just cancel the 5s, and you guys said what? No, you are correct. Okay, remember, they both have to be radical, radicans to simplify like we did. So I have to rationalize this denominator. And the way you do that is whatever the denominator is with the radical, you multiply it by the top and the bottom by that number. So these look like these are going to run together, don't they? Let's just do this. All right, so I go 5 times the square root of 5. And that's all I can do when I do that, just write it. But radical 5 times radical 5, I can make it radical 25. Which is what? 5. So you don't have to write that. You can just write the 5 if you want to save yourself time. So now it looks like what I had up there earlier, right? Now I can cancel those two 5s. So that's our answer. Square root of 5. Yeah.
If you just leave it, like before you cross out anything, is that wrong?
Yes, it's not finished. Probably a point. This is like the warm-up problem, right, for today? So I would do 9 times 2 and 25 times 2 and stop because I like to go a little quicker and make perfect squares here.
Nice, Russell. Nice.
So the square root of 9 is 3 times the 3 that's already there. So that's 9. And the square root of 25 is 5. There's nothing there, so that's 5. Now they're like radicals, so I can add them 9 plus 5 is 14. Questions on 8? Yes, Kelsey?
I'm sorry, I just wanted to take the second to look over what you did and what I did and see what I did wrong.
Remember to see?
Yeah, I'm looking at the whole paragraph.
Well, you mean 3, the 3 to pull it out, you added 36 multiplier, put 6 instead of 5.
Okay.
All right, 227, 375. Okay, simplify again. 9 times 3. 25 times 3. So square root of 9 is 3. I pull it out. Times negative 2 is negative 6. 3 is left. Square root of 25 is 5 times negative 3 is negative 15. 3 is left. Like radicals, so I can subtract and get negative 21. Okay? 6 plus x minus 9 times 7. And x was what? 3? No, 4? X is 4. Right? So, just substitute, and then combine like term, follow Aunt Sally, right? Aunt Sally says, parentheses, there aren't any. Exponents, there aren't any. Multiplication, division, there's multiplication. So we're going to do that first. So it's 6 plus 4 minus 63. Negative 9 times 7. And then just go left to right. Addition, subtraction. 10 minus 63 is negative 53. A squared plus b minus 2a squared. Is it plus or minus 9b? Thanks. Goodbye. Get the b part right? Oh, 3b. Yeah, I thought I messed that up. Okay, so combining like terms, 1a squared, right? There's no number, it's 1 in front. Minus 2 is negative 1, or just negative a squared. 3b plus 9b is 12b, and that's all you can do. You simplify it. Tim, what's the last problem?
2 and in parentheses 4x plus 3.
Ooh.
And negative 3 in parentheses 2x squared minus x.
Thanks. All right, last one. Just simplify. Can I do either of the problems in the parentheses? No, they're not like terms. So I have to distribute. So distributing 2 gives me 8x plus 6. Distributing negative 3 is negative 6x squared plus 3x. So like terms, there's no other x squareds. These are like, that's 11x. And then the 6. Here's your answer. Simple, right? No problem. Pam's got a question?
No, I just have to.
Oh, okay, go ahead.
Wait,
You got to go back to it.
I think I did something wrong. I got 5x instead of 6. Oh, no, I got 6. I got 5x instead of 11. What?
You remember the x
Oh, I
squared?
had negative 3x instead of positive 3x after I fixed it.
Yes, leave it. Okay.
I know like some of these. The amendments? Oh,
There's like
27.
Okay.